Alright guys, let's recap what we talked about in the last video. We are talking about three-dimensional figures. We've learned a lot of vocabulary. Some of the main vocabulary words that we have learned: base, face, edges. We already knew words like vertices. And we started talking about prisms. We said that a prism is a three-dimensional figure that has two bases, and those bases are parallel and congruent. And then we talked about cylinders. We said cylinders are like prisms, except their bases aren't polygons, they're circles, but they're still parallel and congruent. Then we talked about a pyramid. A pyramid only has one base, much like a cone. A cone also only has one base, but it's called a cone because its base is a circle. And we just briefly touched on a sphere. We're going to talk more today about the sphere. So we started working on surface area. We said surface area is when you're finding all of the surface's areas and then you're adding those together, which would be the old-fashioned way to do it. But what we are doing is using formulas. So we started off with talking about prisms and cylinders. And so we have this formula right here. Capital T stands for your total surface area. Capital P stands for the perimeter of your base. Little h stands for the height of your prism. Remember, that means the distance from base to base. And capital B stands for the area of your base. So you have to be able to identify the shape of your base so that you can know, do I need to find the area of a triangle? Do I need to find the area of a trapezoid? Do I need to find the area of a circle? Do I need to find the area of a parallelogram? Do I need to find the area of a rectangle or a square? So you have to be able to identify what shape your base is so that you can do P and B. So we did several examples with that. Then we got to the cylinder, which we said is the same formula. In place of capital P, we're using C, which stands for circumference, which is the same idea as perimeter, which is where the 2 pi r came from. And then also in place of B, because it's a circle, we're using pi r squared, but essentially we're using that same exact formula. And so we did a couple of examples with finding the surface area of cylinders. So today we are going to pick up with pyramids. So let's take a look at some of the vocabulary, and some of it is the same. We still have vertex. That just means where your faces intersect. We still have base, but there's only going to be one of them. There aren't going to be two of them. All of the other faces are called lateral faces, and they will always be triangles. They will always be triangles. So the base could possibly be a triangle, but if you see any other shape, then you know that whatever that shape is, that is the base, because all of the lateral faces of a pyramid are going to be triangles. Altitude, that's the same thing as height. Again, we need to form a right angle. So you'll notice in the picture here that it is going from the vertex to the base. We have this dotted line right here. Notice we see that right angle. You should be able to see a right angle because your height needs to make a right angle with the base. But there's another kind of height that we're going to talk about, which is why typically they call this one altitude, although it still represents the height of the pyramid. But we have what is called slant height. And slant height is different. Slant height means the height of each lateral face, not the height of the pyramid, the height of the lateral face. So in other words, those triangles that we talked about up here, those lateral faces that are always triangles, see this line right here that's a nice solid line? That is a slanted line because it's on the lateral face, which is slanted, but it represents the height of that. In other words, it's going from the top of that triangle to the bottom of that triangle, and it's creating a right angle, and that is a slant height. So that is different from the altitude. Which brings us to a new formula for pyramids. So T still stands for the total surface area. Capital P still stands for the perimeter of your base. L is a new one for us. That is your slant height. So we're not using an H because we don't want to get that confused with the height of a pyramid or a height of a prism. We don't want to get the h confused with the slant height, so we're using a different variable for that, which is L. Capital B still stands for area of a base. You'll notice there's not a 2 in front of it. Hopefully that makes sense, because remember, if it's a pyramid, there's only one base, so you're only going to have the one capital B. So let's take a look at example number 7. I'm just going to start by writing the formula. So T equals 1/2 times P times L plus capital B. Okay, so let's first of all read. It says find the surface area of the pyramid below with a square base. That's kind of important for us, right? What do we know about squares? We know that all of the sides are going to be equal. So in this picture right here, that square down there, we know that each side is 10 centimeters, which is going to allow us to quickly and easily be able to find the perimeter of the base. 10 plus 10 plus 10 plus 10, or you could just do 4 times 10, doesn't matter. Either way, we're going to get 40 centimeters for the perimeter of the base. All right, we also, for the base, want to find its area. That's where the capital B comes from. So it's a square. How can we find the area of a square? Well, you can do length times width, you can do base times height, you can do side squared, doesn't matter. I'm going to go with side squared, so 10 squared is 100. So we have the area of the base, which is 100 square centimeters. But now let's look into the new variable that we have, the L, which represents the slant height. So remember, that doesn't mean the height of the pyramid, it means the height of one of those lateral faces. And it's not drawn on here, so I'm going to draw it on here. So remember, you're going to start at the top of the triangle, and you're going to go down to the bottom of the triangle and attempt to make a line that's straight. I didn't do such a good job. And you should be forming a right angle there. I didn't do such a hot job, but anyway, you get the idea. Now let's talk about this, because if I draw that line down here, this line is going to do 2 things. First of all, it's going to create a right angle. Secondly, it should bisect whatever this segment, whatever the measurement of that segment is. So according to ours, it's 10, so it's going to bisect it. So that means there's 5 over here and 5 over here. And this I'm calling L. That is the slant height. Now notice that it creates a triangle, right? Specifically, what kind of triangle does it create? It creates a right triangle. We know that one of the legs is 5, so I'm using the Pythagorean theorem here, right? The other leg, that's the slant height that I'm missing, so I'm going to plug an L in its place, and I'm going to set that equal to the hypotenuse squared. Now, some of y'all might recognize these numbers, and that would be great if you do, because this is one of the Pythagorean triples that I taught y'all previously this year. I'm going to subtract that 25 over. That's going to leave me with 144. That's good news, because that's a perfect square. So now I know that my slant height is 12 centimeters. So now I have everything I need, and I'm going to come over here and plug stuff in. So I'm going to have 1/2 times P, which we said is 40, times L, which we just found out is 12, plus capital B, which we learned is 100. All right, so 1/2 of 40 is 20. 20 times 12 is 240, and 240 plus 100 is 340. Again, we're doing area. We need units, centimeters, and those units need to be squared. So 340 square centimeters is representative of the surface area. All right, let's take a look at example number 8. We are still dealing with a pyramid. We are still dealing with a square base. Now, as I look at the picture, one thing I notice right away is they don't tell me anything about that base. I have no idea at all what the measurements of it are. But let's take a look at what we do know. We know that the height of the pyramid is 15. Now, that doesn't help us out as far as the formula goes, right? There's no place in the formula for h, the height of the pyramid. This 17 meters over here Do you recognize that? That represents the L. That is the slant height. So we do have L, but in order to find the P and the B, we need to know information about our base, and we don't have that yet. However, what if I were to draw a line right here connecting the height of the pyramid to the slant height of that lateral face right there? I've just now created a right triangle. Well, why do I want to create a right triangle? That's easy, because I want to use the Pythagorean theorem. So I'm going to call this missing side x. So I've got x squared plus 15 squared equals 17 squared. And you guys might not recognize this one like I do. 15 squared is 225. 17 squared is 289. We're going to subtract 225 over. So 289 minus 225 is going to leave us with 64. And when we take the square root of 64, we're going to find out that x is 8. Now, how does knowing x help us? Well, here's what I want to show you. Because this base is a square, the height of the pyramid right here, this dotted line right here, it's going to go from the vertex, and when it hits the square, it hits the very center of the square. So here's what that tells me. That tells me if I were to draw a line this way, these two measurements are the same. And we just found out that this one is 8. Now we know that the other side is 8, which is going to give this a total measurement of 16. So now we know that each side of the square is 16. So let's start with P, because we're going to add all the way around. You can do 4 times 16. You can do 16 plus 16 plus 16 plus 16. Doesn't matter. We're going to get the same answer of 64. We also need to find the area of the base. Again, this is a square. You can do length times width. You can do base times height. You can do side squared. And so 16 squared is 256. So now we have everything we need. And we're just going to come over here and plug it into the formula. So in place of P, I'm going to plug 64. In place of L, I'm going to put the 17. And in place of B, we're going to put 256. All right, let's see. So half of 64 is 32, and 32 times 17 is 544, and we're going to add 544 plus 256, and that's going to come out to exactly 800. And now we just need units, and so we're going to have meters squared. All right, so pretty easy formula to use. You do sometimes have to find information about the base because they don't give it to us. Sometimes we have to find information about the slant height because they might not give it to us. We saw both of those cases in these problems right here. Okay, so cones. Well, remember we said cones are like pyramids because they come to a point, right? And there's only one base. So we have, and here you can see, you could have a right cone, which just means that your altitude or your height makes a right angle here, hits the center. Over here, this would be an oblique cone, kind of looks like it's leaning, if you will. Again, we're going to deal with right cones. And we have this formula right here, surface area for a right circular cone. So we have T equals pi RL plus pi R squared. So pi R squared, hopefully you recognize that as how to find the area of a base. So in other words, that's the same thing as capital B. Let's talk real quick about pi r. Well, you might recognize 2 pi r, right? That's the formula for circumference. What does circumference represent as far as a circle goes? It's kind of like the perimeter of a circle, if you will. So pretend for a second that that was a P instead of C. Then in the other formula that we used for the pyramid, we have 1/2 P times L. So if I took half of each side, this turns into pi r. So this pi r is the same thing as having 1/2 P. So you're essentially using that same formula, 1/2 PL plus B. But for a circle, half of the perimeter means half of the circumference, which is just pi r. and the base is pi r squared. So I'm just showing you that those formulas represent the same information. Okay, so we know r is the radius, L is the slant height, and then you have the area of the circular base right there with pi r squared. So let's get going. I'm going to just start by writing the formula out and taking a look at what we have. So in the picture, I can see that the altitude, otherwise known as the height of the cone, is 24. They've given us 14 feet as the what? Well, that's the diameter, right? We don't want the diameter, we want the radius. So we just have to cut that in half. So that gives us a radius measurement of 7. And what's the other thing that they have not given us? They haven't given us the slant height, which is going to be this side right here. All right, well, what do you notice? Hopefully you see that that is a right triangle. And again, if you have a right triangle, we get to use the Pythagorean theorem. We know that one of the legs is 7. We know the other leg is 24. So I have 7 squared plus 24 squared equals L squared. After a while, when you use the Pythagorean theorem so much, there are certain Pythagorean triples that you will begin to recognize. I already recognize this one, but you might not. But if I square root both sides, I get a 25. So we have the radius and we have the lateral height, and that's everything we need. So we have pi times the radius, which is 7, times the lateral height, which is 25, plus pi times the radius, again, that's 7 squared. So again, we're just plugging it right on into the formula. So 7 times 25 is 175. Don't forget the pi. And then back here, 7 squared is 49. Again, don't forget the pi. Those are like terms, right? Because they both have pi. So I'm going to add 175 pi and 49 pi together, and that's going to get me 224 pi. And let's find out what that would equal. So let's use a calculator. 224 pi. I don't know if I have it on. Nope, I'm good. All right, let's do 2 digits behind the decimal point. So I'm going to do 703.72. So our total surface area is approximately 703.72. What are our units? Feet. So feet squared. So really, once you know the formula, these are pretty easy. Now let's talk about a sphere. This is the last shape. We have an easy formula for the surface area of a sphere, and it is 4 pi r squared. So let's take a look at this example. I'm just going to go ahead and start by writing the formula. All right, so we want to find the surface area of an NCAA basketball that has a radius of 4 3/4 inches. Radius 4 3/4. I don't know about y'all, but I am going to turn that into an improper fraction. That's going to turn to 19/4. So I have 4 times pi times 19/4 squared. And 19/4 squared is 361/16. I can cross cancel because this 4 can cancel out with that 16 to make that a 4. So what do I have now? I have 361 in the numerator, I have 4 in the denominator, and that is pi. But let's use a calculator. And actually, I personally prefer to go ahead and put that pi in the numerator. I like the way it looks better because that's the same thing, right, as pi over 1. But let's use a calculator and see what this equals. Let's see, so 361 pi divided by 4. I'm getting 283.53. So I'm going to say approximately 283.53 units, inches. There we go, inches squared. So if you were trying to cover that basketball, that's the amount of the material that you would need. All right, last example, and then we'll be done with surface area, y'all. So let me just write the formula down first. T equals 4 pi r squared. It says find the surface area of an Olympic-sized volleyball that has a circumference of 27 inches. Ooh, this one's different. So they mentioned the word circumference. So my mind is immediately going back to the formula of circumference, which is 2 pi r. What didn't they tell us? They didn't tell us the radius. What did they tell us? They told us the circumference is 27. So I'm going to plug a 27 in for C. I'm going to solve for r. How do I get r by itself? I got to get rid of 2 pi. How do I do that? I'm going to divide that value from each side. So I have 27 over 2 pi. I encourage you, don't use your calculator right here. Let's use this value because it's exact. If I put it in the calculator now, I'm going to have to round, and then I'm going to use a rounded answer over here, and that's going to change this answer and make it less exact. Let's wait till the end. So let's come over here with the formula. We got 4 pi times the radius, which we just found out is 27 over 2 pi squared. All right, so let's talk about the squaring process first. So if we were to square, and you have to square everything, numerator, denominator. So 27 squared is 729. 2 pi squared. So you have to square both the 2 and the pi. So 2 squared is 4. Pi squared is exactly what it sounds like, pi squared. So look what we have, because this is like a 4 pi over 1. We can do a little bit of cross canceling. We have a 4 in this numerator and a 4 in the denominator, so those are going to cancel out because it's the same thing. We have a pi in the numerator and we have a pi squared in the denominator. Remember, pi squared just means you have pi times pi. That means you have 2 of them. Well, I can get rid of 1 in the top and 1 in the bottom. So what does that leave me with? Well, in the numerator, I'm left with 729, and in the denominator, I'm left with pi. Now, let's see what that would equal. So we're going to do 729 divided by pi, and we're going to get 232.05. 232.05, need some units, inches squared. All right, so we have completely finished surface area. If I'm not mistaken, I think in RenWeb it says that your homework is to do the remainder of that worksheet, numbers 9 through 16, and then tomorrow we will meet on Zoom together, and we'll be doing a review of surface area, because on Thursday you guys have the first half of the chapter 12 test. Again, it's just going to cover nothing but surface area. So I will see you guys at our Zoom session tomorrow when we review for that.